Hey everybody, this is Gregory from Dapp University. So today I've got some more guests on the channel. I've got the guys here from Blockmason to talk about what they're working on. So welcome to the channel, guys.
Awesome. Thank you, Gregory, and thank you with the Dapp channel for hosting us. My name is Harish Rezangani. I'm the CEO of Blockmason, and I've got a couple of my colleagues here with me. Devin, you want to introduce yourself?
Absolutely. Hi, I'm Devin. I'm the CTO at Blockmason and the chief engineer and designer on the Link product that we'll be demoing today.
Awesome. Very cool. Yeah, so I met these guys actually at TruffleCon. That's the hoodie I've got on here. We had the blockchain developer conference about a week or so ago. And yeah, I looked at what these guys are working on, said it was really cool. And yeah, that's how this happened. And we're ready to put on a demo today. So really quickly, before we jump into the demo, you want to give us a high-level overview of what you guys are working on, like what you've built here?
Yeah, absolutely. So the focus for us here at Blockmason is to build tools that enable developers to go from writing code to a live service as rapidly as possible. And we know these types of hosted solutions are quite popular. If you look at AWS, Microsoft, Google, those are fairly compelling offerings. And so with the application that we're demoing today called Link, developers can build, manage hosted microservices which interact with blockchain networks and specifically smart contracts that are deployed on those networks simply by using conventional web APIs. And so that's the product that we're going to demo today, and we're pretty excited. The early feedback that we've gotten is it's one of the easiest tools to use for Dapp development.
Awesome. Yeah, so let's take a look.
Awesome. Okay, so let's dive right in. And maybe just before we start, just building off that intro there, Gregory. When I was at TruffleCon, I recognized you because I've been watching a lot of your videos for my own personal blockchain training. So do appreciate what you've done with the channel in terms of putting together some really interesting content for us to all learn from.
Awesome. Very cool. Yeah, I appreciate that. That's great. I've had some good feedback recently. Had some more people at TruffleCon say some similar kinds of things. So I'm glad somebody's getting something out of it.
Awesome. Okay, so let's dive into the demo here. And I'll just point out that we do have under our GitHub repo, we do have an onboarding page. So it kind of walks through a lot of the details that we'll be covering today in terms of getting set up. And then we'll also be doing a demo here using our microservices demo repo. So for viewers, definitely recommend cloning that repo to be able to follow along in real time. So when a user creates their account and first logs into Link, this is the interface that they see. It's the Link IDE. And what you see here is a demo contract that's automatically loaded up for you. And you'll notice that there's this toggle here between the code and the API. And when we click on the APIs, that's effectively the API endpoint that a user can access to be able to interact with this smart contract, and specifically the smart contract function called Hello World. It's really that simple.
Cool.
Yeah, we'll go through interacting with this, but I just wanted to point out that the intent here is to keep the interface relatively light and clean, so users can build their code. Under the hood, we've got our Link private network that's running. So this contract here in the IDE automatically gets deployed to the Link private network. And so what this means is if you're a developer and you want to get up and running, you don't need to go to an exchange and get some ETH. For example, if you're developing on Ethereum, you don't need to get any utility tokens. You don't need to be using any complicated Web3.js or any of those types of libraries. You've got your smart contract translated into an API that you can use immediately in your front-end application. So you can use your programming language that you're most comfortable with.
Yeah, very cool.
So this is obviously a very simple example. Let's take a look at something a little bit more complicated. So in my VS Code here, I've got a few different contracts. And again, in our GitHub repo, we've got these smart contract templates available. So I'm just going to copy and paste this ownership contract. And once I do that, I'll talk a little bit about what this is. So the ownership contract here is simply a mapping between some sort of asset that's represented by a string and the corresponding address, the Ethereum address of the actual owner. And we have a few functions here. We've got the getter, because this is a public variable. We've got the getter for the owner of mapping. We've got an authority, that's the owner of this contract. And then we've got this set owner function where you pass in the asset, the owner, and then it stores it in this mapping. And if we now click on our APIs, we see that this has been updated to reflect the endpoints that we just talked about. So being able to post to the set owner endpoint, being able to get the owner of by passing in the asset value, as well as the authority of who owns the contract. So this is kind of neat. We can get the APIs. How do we actually interact with them? Well, there's a couple ways. I'll show you sort of the easy way here. Off our website, we actually point out that we've got a handful of SDKs in a variety of different languages. So we've got JavaScript, we got Java, we got .NET. And what this will allow you to do is very easily interact with these API endpoints. There's this gear icon here, and when I click that, what you'll see at the bottom of the screen is a client ID and a client secret, and this is effectively how you will authenticate with Link to be able to utilize those API endpoints. And so if we take a look at a sample script here, so we've got a Node package manager for the Link SDK for JavaScript. So I am just pulling that in there, and I'm pulling in Node fetch. I'm going to create this this project variable that represents this Link object, and all I have to do is pass in the client ID and the client secret. And now I've got this project object that's going to have the ability to get or post to the API endpoints that are available here. Let's actually see this in action.
Yeah,
so
cool.
Let me just copy this client ID here and the secret. Okay, and all we're doing is we're calling, we've got the set owner function where we're going to assign some sort of painting string, so a DaVinci painting and an owner. We're going to make that post request using this project variable here, and we're going to call that set owner endpoint. And then we're actually going to retrieve this asset just to make sure that what we get back is the correct owner. So we should see this this gets sent back. Okay, so let me just run this. And again, this has been deployed on the Link private network. So we'll take a look at where this actually got triggered. There isn't a formal blockchain explorer for the Link private network yet, but we do have audit logs so we can see if this actually was triggered. So we see that the post request was successfully made, and then when we made the get request, we were able to get the value back. So let's just take a look at so down here at the bottom left here, we've got the audit logs, and we can see we just set the owner and we call the owner of. So we've got indicators here highlighting that those functions were actually just called.
Yeah, very cool. And is this something that all the logged in users will be able to see for their own activity?
Exactly. So we'll kind of go through this process in a little bit more detail of creating multiple projects. But with each set of projects, you've got your own set of APIs that you can call. And so you'll get an audit trail here of all the function calls that are being made for your specific account.
Cool.
Okay. So that was just a very simple demo of using the Link SDK. We used the script. Let's take a look at what a front-end application could look like and how we can interact with that. So with this microservices demo, we've got a a simple front-end project that we built. So I'm just going to fire that up right now. And it's just getting built. Okay. Let me just refresh that really quickly. So this is what we've got. This could represent any sort of digital asset e-commerce type of platform here. And so we're just representing this with some collectible paintings. And we've got the ability to enter in an ownership address. And the ownership of that asset will get recorded on a blockchain. And so we just showed how to interact with the smart contract, that ownership smart contract that we deployed on the Link private network. But what if you actually wanted to use a public network, let's say Ethereum, or we've recently announced a partnership with GoChain, which is also an Ethereum compatible blockchain. What if we wanted to use one of those public blockchains? How would you actually go about doing that? And what's really cool about Link is you can use any of these public blockchains, or you can actually, quote unquote, bring your own blockchain, BYOB, used in a very different context than what I'm used to. And so you've got the ability to interact with your own network or use any of these public networks. And currently, if it's Ethereum compatible, we'd be able to interact with that using Link.
Awesome,
so let's
very cool.
So let's go through and actually deploy the ownership contract that we just did on the Link private network, and we're going to do the exact same thing, but we're going to use a public network this time. Let's do this on GoChain first, and I will show you why. So on the GoChain website, all you really need to do is utilize these network RPC URLs, and this is effectively how you connect with those with these public networks. Let me just show you a quick diagram of the process that we're going to go through in Link, and this will help clarify where the role of this network RPC is going to come into play. So you've got the Link application. As we just demonstrated, you have the ability to create your smart contracts in the IDE. These smart contracts will be written up in the Link application. We talked about the Link private network, but we also have the Ethereum and GoChain public networks that we want to interact with. So we just need to label that particular network. We then need to connect to that network. And with the GoChain, as we just saw, we've got this URL that we can use. The most common way that's used by developers to interact with Ethereum is through a third-party sort of hosted service commonly used with Infura. So Infura provides an API that allows you to connect with any of the different Ethereum-based networks, so the main net as well as a host of different test nets. So we just need to connect to the network. We will then deploy the contract to that particular network. And then we label the API. We label the front-end API consumer that's actually going to be using and making the calls to the API engine. And then we've also got the OAuth authentication mechanism in place. So with the client ID and client secret, we get an access token back, and that's the token that's used to make those API calls. So that's just a sense of what the flow is going to look like in Link when we try to use a public blockchain.
Yeah, cool.
Okay, let's do this. So in Link, we'll go and we will create a new project. We're going to create a new contract. This is going to be our ownership contract here. So let me just copy and paste that. And we'll call this ownership. Okay. We'll use a default Ethereum account. So with Link, there's actually a managed account. And one thing I should mention is when we are using a public blockchain, Any developer who's interacted with such blockchains is probably familiar with the concept of having to use a utility token for that particular network to pay for transactions, known as sort of gas fees. And so with Link, there's actually a hosted wallet that allows you to use that wallet to pay for those types of transactions. And so if you're interacting with a Dapp today, you'll notice that when you try to interact with that application, the first thing it's going to do is try to connect with your browser wallet, for example. If you're a user who's not necessarily familiar with these Dapps, the first thing an application doing asking access to your wallet is a bit intimidating. My colleague Devin likes to mention it's like going into a grocery store and having to provide your wallet to the shopkeeper first before you can actually go in and buy some goods. And so we're trying to get away from that type of relatively jarring experience when the first thing you have to do is provide access to your wallet. So Link actually has a managed wallet for you that takes care of those types of transactions. You just need to seed that wallet with some of the utility tokens for that particular network. I can show you really quickly where that is. So there's this wallet icon here, and so this is the hosted Ethereum address where you can send some test Go if we're using the Go chain testnet, or some test ETH if we're going to use the Ethereum network. So I've already seeded some test utility tokens to this account.
Yeah, very cool.
Okay, so ownership. We're going to use a default account. We're going to create a new network name. So this is going to be the Go chain testnet. We're going to use the Go chain connector, and you'll see here this is the URL that we saw here in the documentation. So this is the network RPC URL. So I'm going to copy this one for the Go chain testnet, and we'll save that. So now we have the ability to connect with that particular blockchain. We're going to call this ownership Go chain deployment. So if there is a contract that's already on the network, we can actually just find its address and paste it in here, and Link will be able to connect with it. But because we haven't deployed it yet, we don't have an existing address, so we'll leave that as it is. We'll use a default account, the ownership contract. That's our network. So let's save that. And then it'll ask us, are we ready to perform this deployment? And we'll just click that. So if you can sort of contrast that experience with having to deploy using some of the other tools in the past. Again, the idea is to make it relatively easy using Link to be able to deploy things to networks. Okay, so let's call this the ownership Go chain. That's going to be our API. Great. Our consumer is going to be, let's call this a collectible asset app. So that's our front end. We'll get our OAuth client. Okay, and so there are our APIs, our set owner, owner of, and our authority. And under authentication is our client ID and our client secret, similar to what we used before. Let's actually just check and see that this contract got deployed as expected. So under this icon here, we see our ownership Go chain deployment, and we've got this address here. And so what we can do is we can go to the Go chain Explorer, and we can just search for that. And we see there's no transactions yet. And that's fine, but it has been deployed. So let's actually go and create a transaction and see if this updates. So if we go to our front end application, well, first what we need to do is we just need to get our credentials to be able to authenticate with this. So our API documentation. So what I'm going to do is I'm going to copy my client ID here and go into my code. Now, obviously, I'm using, .env to pull in the credentials. I'm just going to paste this in here, but obviously you should be using a .env file or something and not have your credentials in the front end like this. This again is just for the demo. So let's copy our client ID and our client secret. Okay. And let's run our app and let's see if this actually works. Okay. So I'm going to just take an address here. I'm actually going to just copy my MetaMax browser address here to use for this example. And let's see if this is actually going to assign it. So I'm going to click own. It's going to confirm that. And so what we're doing here is we're trying to record ownership of this particular digital painting on the GoChain network. And so we see that this registered. Here's our owner. And let's see if this transaction took place as expected. So if we go to the GoChain Explorer, and we see there's our transaction. So we just plugged in a GoChain testnet into our application, and we're able to record ownership of that asset on this particular network. And so you can do the same thing deploying to any Ethereum compatible network that's got a JSON RPC API that you can use to connect with it, or Infura, which is a pretty popular third-party service. So again, recording ownership, that's a pretty neat application here. We've also tied in a payment network, and I've already pre-deployed this contract here. So I'll just show you what it looks like here. So we created our own custom ERC20 token. There's actually a tutorial. I'll show you the link in just a second here, but you can go about creating your own custom ERC20 token. We created one called the asset token, and here are the APIs for that particular token. And so we'll use this to actually transfer ownership from one user to another. And so if I wanted to, you can see that there's a sort of a price set per each of these asset tokens. So the current owner is this one here. So let's just make sure that I can't just, re-own something that I already do. I'm already the owner, perfect. And now what I'm gonna do is just take another account. What I'll do first is show you that I've got 7 asset tokens with this particular account. And I currently own this the city of Petra, and it's worth 7 asset tokens. So the next owner is going to have to pay me 7. So I should see this update to 14 if this actually works correctly. So let's just pick account 2 to be the new owner, and I'm going to paste that address in here. Let's click own. Okay, so it's just processing here. And because we're using the Ethereum testnet here, it'll take just a little bit longer. We've seen that performance-wise, we do get better performance at a GoChain. But because Ethereum's got a really nice and complex suite of blockchain explorers, when we're doing things like payments, there might be a preference to want to use the Ethereum network. But this kind of just highlights sort of the fundamental value that we're able to offer with a tool like Link. No longer are developers constricted to using just one particular blockchain. They can basically pick and choose the features that they like across a variety of different blockchain networks, and then plug in those different networks and then use them for the particular feature that they want to take advantage of.
Yeah, very cool.
Okay, so we see that this ownership just updated here. And let's see if this, we want to check and see that account 3. We now have 14 asset tokens here. So account 3 just got paid, 7 asset tokens here. and we've got a new owner that's assigned to this particular asset. And so, from a front end perspective, I can literally just go into my code here. And what if I were to change this from asset tokens to something like a fiat, like USD, for example? And I've got my payment service here, and let me just change the conversion rate. So all I'm doing now is, from a front end perspective, this looks and feels like any other e-commerce site. I don't even really know that blockchain is necessarily tied in under the hood. And that's also part of the goal and the value that we're trying to achieve with a tool like Link is, you think of all the projects currently that use, AWS's EC2 for storage. A lot of the times these projects, the participants don't even really need to know the details of what EC2 is, how it works, any of load balancing, any of that stuff. That complexity is just abstracted away. They're able to get up and running relatively quickly in building something and have this external storage. It's sort of the same concept that we're trying to achieve with Link, where you can build these microservices, be able to utilize these blockchains, but not necessarily have to understand all the technical nuances and details that blockchain tech currently entails. And so I'll show you one last thing, and then we'll pause it here, because this is kind of a cool feature that I don't think I've seen in any demos so far. So we're actually going to tie in a third blockchain here. So what we're going to do is just have the ability to post comments on each of these different assets. So what I'm going to do is I'm just going to uncomment this part here, which is sort of our comment section. So now we have the ability to post a comment in here, we've tied in a few comments here. But let me actually just deploy this on another blockchain so that we can see this relatively from a fresh perspective. So this is the comments contract. Very simple. It's just the asset and the corresponding comment to it. And what I'm going to do is let's just deploy this to the Link private network here. So go to my IDE here. Let's delete that. Let's paste this. So it's just an asset and a corresponding comment to that asset. And then we've got this ability here to post the comment. And so what we should expect to see here is the ability for making this post request, and then be able to get all our events. So there's our post comment, we get the authority, and we can get all our comments here. So let's just take our client ID. I'll go to my comment service, and I'm going to paste that in here. And I'll do the same thing with the secret. And again, taking advantage of the Link SDKs to make this as easy as possible to use. All right, great. We've tied in now this comments microservice into our front end. Let's have a look. And I can say this is a beautiful painting. Perfect. And now this actually is being recorded on the Link private network, and we can just see that by going back to our audit. And we can see that, looks like we've got a bunch of other stuff here. It's only showing the first 10 here. But we actually are recording this on the Link private network. So 3 different networks, 3 different microservices, all tying in to a very simple front-end application. And that kind of demonstrates the power of Link to have this ability for interoperability, plugging in different networks and trying to abstract away as much of the complexity as possible.
Awesome. Very cool. Well, that was a great presentation. You guys did a really good job. I'm super impressed, super excited what you all are working on. So if people want to go get started today, how do they do that?
I'm glad
what links?
So blockmason.link is our starting point here. So here you can get, when you click get started, you can set up your Link account, and boom, you can get up and running immediately. We do have a handful of tutorials. So we have gone through and put together examples of creating a social network that's powered by blockchain, using a different network, retrofitting. This was the brainchild of our CTO, Devin, who tied in a blockchain economy into that fantastic Ultima Online game from 1997, and being able to plug in a blockchain backend to any sort of app, as well as creating your own custom ERC20 token in just a few minutes. So we've got some tutorials, and then we also encourage folks to join our developer community as we solicit feedback, try to improve the application, but also as we come up with new features, we're definitely sharing that with our dev community. Yeah, it's just a great place to solicit some feedback to improve our application.
Nice. Very cool. Well, guys, thanks so much for coming on the channel today. Like I said, I'm really impressed with what you all have done. This is a great presentation. It's a great product that you all are working on. I've seen, lots of cool features that I haven't seen anywhere else. So, again, I'm gonna put some links down in the description below for you guys to check this out and get started for Blockmason. So, also on social media, can you guys find you anywhere?
Absolutely. We're on Facebook, Twitter at the bottom here. We've got all our social media links here.
Cool. Awesome. Well, guys, again, thanks so much for coming on the channel today. Go check out Blockmason. Any last words before we sign off here?
No, thank you so much, Gregory, and thanks so much for hosting us on this Dapp channel. And look forward to seeing some really good, high-quality content continue to be built on your channel. Yeah, totally. Awesome, guys. Well, thanks again. Everybody, subscribe to the channel. Click the link button down below. And until next time, thanks for watching Dapp University.